Okay, 12, it's lesson 12.2, measures of central tendency. We're going to find and interpret the mean or average. We're going to look at mean. We're going to find and interpret the median and also the mode of a data set. We're going to look at infer central tendency measures for stem and leaf displays and discern symmetry in data set. Okay. Measures of central tendency. That's basically, we're looking at where the data set clusters around the middle or the central part of the data. So we're going to look at some properties. The first one is the mean, and basically that's just the average. So like if you were trying to figure out your test average, you add up all the tests, divide by the number of tests, and that's your test average. Well, mean is the same thing. And there's basically, we look at two types of mean. One is a sample mean, denoted by X bar, and the other one is the population mean, and that's just annotated by the Greek letter mu. It looks like a kind of like a backwards U. So let me let in just more. Hello. We are working on lesson 12.2 and measures of central tendency. And basically, we just got started. This is really the first slide. Well, we're talking about the mean, which is basically just at the average. X bar is the sample mean, mu is the population mean. You could look at the population mean being all the, let's say, math averages, overall average for entire Livingstone College. That would be population. Whereas sample is if we were to take just the average grades in this class. So that's the difference between sample and population. Okay. So mean is noted by N is the number of data items. So like if our class, I believe, is 18 students, then N would be 18. And then the data items would be like the tests, like test 1, test 2, test 3, test 4, and so on. Whereas this E looking symbol, that's the Greek letter, that's our Greek letter sigma, and that symbolizes the sum, where you're adding up, like you're adding up all the tests. So sigma is just the sum, or adding up all the items over the total number. Okay. So here we have 10 students in a class. So let's take a look at this problem. So I'm going to switch to working this on paper. All right, so if we have 10 students in a math class were polled as the number of siblings in their families, and the results were first student had 3 siblings, the next one had 2, 2, 1, 3, One of them had actually 6 siblings in it. 3, 3, 4, and 2. And we want to find the mean. So basically, the mean is the sum over our total. So basically, this would be 3 plus 2 plus 2 plus 1 plus 3 plus 6 plus 3 plus 3 plus 4 plus 2. And you count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is 10, and you add all these up, and you get 2.9. And so 2.9 is your average number of siblings per student. Okay, find the mean number of siblings. So we did that. Okay, the weighted mean. So if we go back to our slides again, the weighted mean is where we have the sum of our items times some weighted number. Like they put a weight to each number over the sum of all the weighted items. So weighted mean your basically your GPA is considered your weighted mean. So usually for a grade point average, A is considered 4 points, B is considered 3, C is 2, D is 1, F is a 0. So A is considered. So if we were to look at that, so if we have here on our paper, A is 4 points, B is 3 points, C is 2, D considered 1 point, F doesn't count as anything. So if, let's say we have a student and they want to know what their GPA is from the classes that they're taking. So he's taking a course and then grade points.
You better not.
What's that? What's that?
Oh, sorry, I wasn't talking to you.
Oh, all right. Units. So we have math. Let's say the student has taken a math class, a history class, a health class, and an art class. And math, the student's getting an A. And it's a, so that would be 4 points because A is 4 points. And it's a 5 credit class. So history, they're getting a B, and so that'll be 3 points. And the history class is 3 credits. Health class, he's getting an A, and so that's 4 points again. And so that's a 2 credit course. And art, you're getting a C, and so C is 2 points, and that's a 2 point credit class. Okay, any questions with that so far? Okay, so what we do here is from here we multiply.
Go to his
What? Oh. We go ahead and we multiply grade points. That would be considered X. Units, that would be considered F. So we want to take these two and multiply them together. So 4 times 5 rather is 20. 3 times 3, that would be 9. 4 times 2, that would be 8. And 2 times 2, that would be 4. So if we were so for our F total, that would be 12. If we were to add all these up, 5 and 3 is 8, 8 and 2 is 10, 10 and 2 is 12. And if we were to add all these together, 20 and 9 is 29, 29 plus 8 is 37, 37 plus 4 is 41. So that's our X times F total. So our grade point average would be, and if you looked at, so if we looked at our formula right here, back it up, that's our sum of X times F over sum of F. So get back to here. So our sum of X times F, that's this column here where we multiply the two columns. And then the sum of our frequency or our units is 12. So we're taking the grade point average, the grade times the number of units to get the column to the right, and we're going to divide that by the number of hours, right, the student is taking. So that'll be 41 over 12, and that gives them a GPA of 3.42. All righty, any questions with that? Hutchison. There we go. Okay, so that's how you figure out GPA.
is that?
Any questions? Um,
May I ask what are we going over today?
yeah, we're going over lesson 12.2, measures of central tendency. And
Okay,
we've
great. I have a
gotten,
lot of questions.
so back up. This is where we started. Okay, we talked about measures of central tendency. We talked about the mean, which is the average. It's basically just the same thing as you figure out your test average. And we looked at a couple of examples, and we just did weighted mean right here. And weighted mean is like how you figure out your GPA. Okay, so this is as far as we've gotten. Okay, median. Median is basically the middle of your data set. Think of like an interstate, and you have traffic going one side and traffic going another way. In the middle, there's a median, like it's usually grass, sometimes it's concrete, but there's a median in between them. So median tells you the middle data set. And why do we use median? Because we can tell how skewed our data is by comparing the mean by the median. If it's too far off, then our data is skewed, or also known as, also you could also say in layman's terms as distorted. Okay, so median is basically just divides the data set in half, and it gives you the middle number. Okay, so the median. First thing you want to do is rank the items from lowest to highest, and I'll show you how to do that on the calculator. It's real easy. Okay, and if the number of items is odd, then the median is the middle number. If the number of items is even, then the median, you take the two middle numbers and you take the average of the two middle numbers. In other words, you take the two middle numbers, add them together, and divide by 2. So you can't find the middle number for even number of items because the middle is right in between the two middle numbers. So you have to take the average of the two middle numbers. Okay, so here we have a data set here, and so we've got 3, 2, 2, 1, 1, 6, 3, 3, 4, 2, and we want to find the median to that. Okay, so let's take a look. Okay, so here's our paper. All right, what we do is everybody should have a TI-84 on their cell phone. Okay, so if you don't, just go to your app store and put it on there on your cell phone. So let me lower this down a little bit so you can see better. And I always have to darken this, the exposure on it. The other way. There we go. Okay, so you go to your app store and you download TI-84 calculator on your cell phone. Okay, so this is my icon here. So we go to that, and steps. You want to write these steps down because this will help. The steps, first thing you want to do is enter the data. Okay, and so to enter the data, you go to stat. You go to stat right here where it says stat. You go to that, and then you're going to go to edit, which is right here, and then you're going to enter your data. And notice it says L1. So you're going to go to stat on your calculator, and then edit. And then you're going to enter your data. Okay, so we have here 3. So we put in 3. And notice this says, this L1 means list 1. So this is list 1, item 1. There's a 3, hit enter. Enter. There we go. and you can see the 3 in the list. So next one is a 2, so put 2, and see there's now item 2. So hit enter, and see there it is. So we just keep on going. 2, and you want to check it, make sure you entered it right as you go along, because if you make a mistake, I'm trying to talk and do this at the same time, not make a mistake. Sometimes that's not so easy. And then a 3. So you want to enter this and check it, so that you enter your data incorrectly. And then the last one is a 2. So get out of here. Okay, so that's that. So you've entered the data in, and so now we want to hit exit. So from here, hit second and quit, and you come on out of there. Okay, and then from there, you're going to sort it. So next thing we're going to do is sort. And to sort the data, you go to sort. You're going to go to stat again. And then you're going to go to sort A. Okay. So you're going to go to stat. Do this in blue. You're going to go to stat. And then you're going to go to sort A. Okay. And then you're going to go to L1. So you hit sort. And notice it says sort A. And you're going to put in L1. Well, L1 is down here. Well, you have to hit the blue second key and then L1. Second, L1. And notice there it is. Okay, close the parentheses. So you're going to put in second, L1, and then you're going to close the parentheses. I always like to close parentheses. You could do it without closing the parentheses, but it's always a good idea to get in the practice of closing the parentheses. And then you're going to hit enter. Okay, so we hit enter, and there it is. Your data items are in order. And I have decimal points because the mode, you can do them in integers, but we'll go ahead and just use data as what we have for now. So notice there's 2 1s, there's 2 1s, and then you can hit the right arrow to, where are you? And so now if you go back to look at it, okay, you're going to hit second, list, L1, enter, and then enter again. Okay, so let's look at that. You're going to go to second, and then L1, or second, I'm sorry, second and list. Clear that. Second, list, L1, enter, And there it is. And you can, okay, this one's nice. You can just scroll it back and forth. The others, you had to right arrow, but this one, you could just slide it back and forth like that. And now your numbers are all in order. So since we have 10 items, right, you've got, because we counted them, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have to go 1, 2, 3. So you've got here, so if you look at this, this is, get out of there. You got 1, 1, 2, 2, 2. You got 1, 1, 2, 2, 2, 2, 2, 2, and then 3, 3, 3, 3, 3, 3, 4, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you count 1, 2, 3, 4, 5. So it's 5 and 6 are the two middle numbers. So you have to take these two, 2 plus 3 divided by 2, and you get 5 over 2. And so your median is 5 over 2 is 2.5. And that's your median. Okay? Questions there. Let these other people in. None. Okay, any questions there? Okay, so let's go back to our PowerPoint again. And so notice they have 1, 1, 2, 2, 2, 3, 3, 3, 4, 4. So you have 1, 2, 3, 4, 5 on the left, 1, 2, 3, 4, 5 on the right. So the middle is in between 2 and 3. So you have to take 2 and 3 and figure out the average. You take those two, you add them up and divide by 2 to get the average between those two middle numbers. And that's your median. So your median divides the number of items on the left and the number of items on the right. So we got 5 left, 5 right. And so our median is 2.5. Alrighty, any questions there? Okay. When there's a large number of items, data, and we put them into like a table or we sort them out, we can use what we call position median. And so from there, position, what we do is to find the median is first we got to find where the position is. So you use n plus 1, n for your number, plus 1 over 2. Okay, so let's see how that works. So here we have a frequency distribution where here in this case we have 4 1s, 2 3s, 2. We have 3 2s rather, 2 3s, 6 4s, and 8 5s. Well, you'd have like a real long string of numbers. So they put them in a table to make it more manageable. So what we do here is we add these up. So if we looked at this, we have a value and frequency. Okay, we've got 1, 4, 2, 3, 3, 2, 4, 6, 5, 8. Okay, so this is what we've got. This is our table, okay? And so we take, looking at our position median is n. So we have to look at the total number. So if we were to write all this out, right, we'd have 1, 2, 3, 4 ones, 3 twos, 2 threes, 1, 2, 3, 4, 5, 6, 6 fours, and 8 fives. 2, 3, 4, 5, 6, 7, 8. So that's pretty lengthy. So we use this table here to help us kind of make it more manageable. So what we do here is we add up all the frequencies. So we've got 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 6 is 15. 15 plus 8 is 23. So our frequencies is 23. So if we run out of time, just come back in on the same URL that we were at before. Okay, so we add them all up and we divide it by, and we get 23. So we're going to take 23, add 1 to it, and divide it by 2. So that gives us 24 divided by 2 is 12. So position 12, that's just the position. Position 12 would tell us what our median is. So we go back here, 4 and 3 is 7, 7 and 2 is 9. Well, we want to get to 12. 12 plus 6 is 15. So 12 is going to be in the 4s. So therefore, our median is 4. Well, let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's our median. Well, instead of going through all that, you could just add up all the frequencies and add 1 to it and divide by 2, and you get the position, and then from there you go back to your table to get your median. All right, questions with that? Okay. Mode. Mode is the most frequent number of items. Bimodal is where you have more than one mode. So if we looked here, we said that 4 is our median. Well, we want to look at what has the most number. 5 has 8. So 5 would be our mode because there's the most number of 5s. So that's mode. If there's 2 of them that are equal, then it's bimodal and you count them both. So here we have 3, 2, 2, 1, 3, 6, 3, 3, 4, 2. So 3s occur most often, so our mode is 3 for the number of siblings. Okay, questions with that? All right, and so here we just went over that one. We said our mode for our frequency table is 5 because there's 8 5s. Okay, central tendency is stem and leaf display. Basically, we've looked at stem and leaf display before, and so if we wanted to find the median, we would add all these up and divide by n. So in this case, our median is 37, and our mode, because you count, this is the tens digit, and so our mode would be 42. So basically, you would have to add these up. Okay. So in our stem and leaf display, it's like you're adding up 15 plus 16 plus 20 plus 27, and then so on, plus 28. So you're adding all these up, plus 29, plus 29 again, plus 36, plus 36 again, plus 37, plus 37, plus 40, plus 42, 42, 42, plus 42, plus 42 again, plus 43, plus 46, plus 51, plus 56, plus 58, plus 58. Okay, so you add all those up, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19. So you add those up and you divide by, I believe it's 20 data items on there. And you get your mean, which would be, so you, and the median would be, you're looking at, here you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So you take 21 plus 1. So, and then divided by, so you've got 21, right, items. And so you would take your middle 21 would be 10 left and 10 right. So here your median is 37. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your median is 37. Your mode, most frequent, is 42. Most of those. All right, questions there. All right, symmetry is basically just like symmetry on a quadrat. Looking at a graph, it's the same on the left as it is the right from the middle. So this would be considered a uniform distribution where all the data are the same. Binomial distribution is where you have a nice even distribution, same number. It looks the same on the left as it does the right. The middle is your mean. Here's bimodal, where you have like two middles. And so that's what that looks like. Skewed data is where it's a little off. It looks more like a J, skewed left, the tail is on the left, skewed right, tail is on the right. So it looks like it's skewed to the right, but it's not. It's the wherever the tail is, that's where it's skewed. So this is skewed left, and this would be skewed right. And then this is a bimodal distribution. So a lot of people misinterpret skewed data, data graphs. They think this would be skewed left, but it's not. It's skewed by whatever side the tail is on. So this is skewed right and skewed left. All right. Any questions with that? Okay, and then